Hello and welcome back to 1.2 Writing Rational Numbers as Decimals, the independent practice from Math and Focus Singapore Math Student Edition Course 2A. I'm sure you had an opportunity to go through the video that takes you through the concepts of this chapter, and you are ready for the independent practice exercise over here. So let's begin. The first part here says, using long division, write each rational number as a terminating decimal. Okay, so we have terminating decimals, right? So when you do that operation of dividing, the end result, the remainder will be 0. It will terminate, right? It's not repeating. So let's get started with the first one. The first one is 76, 1/2. Okay, so as we have said before, we don't need to touch this number when we are trying to do the division like these and getting answers in the decimal format. So we will leave 76 as it is, and we'll only work on 1.5 at the moment. Sorry, half. Okay, so 1/2. We all know what it is, right? It's 1 divided by 2. So when one thing is divided into 2, it results into half. Right? So this answer will be simply, you take this 76 as it is here, okay, and this comes here. So this is 0.5. So this is the answer. Okay. Next we go here, minus 39, 2/5. So as we did here, we will leave 39 for the time being, and we will work on 2/5. Okay, 2/5. Now assume that it was 20. Okay, if it was 20/5, you know the answer was 4, right? 4 times 5 gives us 20, but this is 2. So if 20, when you divide 20 by 10, you get 2, right? So this gets cancelled. So it's simply dividing by 10. When you divide by 10, you know the decimal point is put over there, right? So when it's 20 by 5, it's 4. So if it was 10 by 5, this will become 0.4. Okay, so you shifted, right? So decimal point is over here. Okay, so this answer becomes 39 from here, and this number comes here, 0.4. So this is how you get your answer. This is how you try and do faster math, okay? Else you can just do this work, 2 divided by 5 and go on. This is the way to go fast, okay? Then next is simple, minus 47/10. There's 10 here, right? So it's a matter of putting a decimal point there. So it's minus 4.7, right? 10. So we take from here, we take 1 digit and put a decimal point. Okay, let's move to the next one, which is 5/16. So this one we will actually divide to get the answer. Okay, so 5 divided by 16, right? So we know 5 is a small number, so this is not possible. So we will have here a 0, and here we will put a decimal point. Okay, 16 times 3 gives us 48, right? So the remainder is 2. We put 0 again. 16 times 1 is 16. 4 is the remainder, right? It says terminating, so we have to terminating, so we keep going. Okay, then you put 0 again. 16 times 2 gives us 32, right? The remainder is 8. We put 0 here. 16 times 5 gives us 80, and you have your remainder 0 terminating, right? So the answer is this, 0.3125. Okay, so it was a simple division over here. Then you have 7/20. Okay, now again we'll try and do the smart math here. When we have 7/2, we know that this is 3.5, right? But this is not 2, this is 20. You have additional 10, like additional 10 in the sense 2 times 10, right? So this is this extra 0, and then you know you have 0, you keep shifting a decimal point to the left, right? So this would become 0.35. Are you understanding it? Okay, so you could write like this: 7 over 2 times 10, right? So 7 divided by 10 would be 0.7 over 2, right? If it was 7 by 2, you would say 3.5. This is not 7, this is point. So this decimal will shift here, so it becomes 0.35. Okay, so try and do these tricks with your questions, and you will be faster. You will master math easier. Okay, and that's how you usually do it, to become faster at it and to enjoy it. Okay, the next we have is 7 over 8. So let's do the actual division here. 7 divided by 8, right? Smaller number, we put 0 and we put a decimal here, right? So 8 times 8 gives us 64. The remainder is 6. We put 0 again. 8 times 7 gives us 56, right? The remainder is 4. We put 0. 8 times 5 gives us 40, and the remainder is 0, terminated, right? So the answer is the 0.875. Okay, so this is what we had to do here, long division method. We followed that and we got the answer with terminating, right? Next, what we have is simplify each rational number, then use long division to write each rational number as a terminating decimal. So first we need to simplify this number and then do the same process here. Okay, we could, if we do directly, this division will become a bit tough, bit long, and we'll need to know tables which are like higher number tables. So we will simplify them, okay, and simplify, make our life easy. So we know 99 and 36. Try and get the factors in a way that you can cancel easily, okay? So 99 and 36, you know, both has 9 in it, right? So 9 times 11, this is 9 times 4. So I will say 9 times 11 over 9 times 4. I will not say 3 times 3 times 11 or 3 times 3 times 4, because anyways I'm cancelling them, okay? So as I said before, I'll always prefer using my pencil to cancel out the common terms. So this leaves us with 11 over 4. Now we do the long division method here. See how easier it is. 99 divided by 36 versus 11 divided by 4. So you know this table is easily a 4 table, right? So this becomes much easier. So even if it's not asked in your assessment or in your tests, simplify. Try and simplify first, okay? So 4 times 2 gives us 8. This lives with 3. We put 0 here and a decimal point here, right? 4 times 7 is 28, with remainder 2 here. We put 0, and this is 4 times 5, and it terminates, right? So the answer is 2.75. Okay, so that's how you have to do for the rest of the sums over here. So 12 and 15. Let's find the common one. You know, this is 3 times 4 and 15 is 3 times 5. So we'll write it 3 times 4, and here we write 3 times 5, right? So we'll cancel our common terms. 3 and 3 is out, and that means our division is only 4 over 5. Okay, now again, you can be smart here. Okay, you know 5 times 8 is 40, right? But this is 4 and not 40. So it's basically 10, 4 times 10 is this, right? So if you divide it by 10, you get this. So similarly, you divide this by 10. So your answer is actually 0.8. If it was 40, the 40 over 5, right? So answer would have been 8. But this is 4 over 5. Okay, 10 times 10 is out. So this becomes 0.8. You divide this by 10, you divide this by 10. So this is how you get your answer. If you want to, you can do with the division as we did here, and you'll get the same answer. Okay, so the next one is 9 over 48. So we'll have a common factors again, right? So 9, we know it's 3 times 3, and 48 is 3 times 16, right? So we write it here, 3 times 3 over 3 times 16. Okay, I'm putting my factors in a way that the cancellation is easier. So 3 and 3 is out, right? So that leaves us with 3 over 16. So now we carry out the division. So this is 3 divided by 16. Okay, so this is not possible. So we put 0 and a decimal point here, right? So 1 times is 16, right? This leaves us with 14. We put 1 more 0 here. Now comes your tables, okay? 16 times 8 gives us 128. Okay, the remainder is 12. We put 1 more 0 because we say it's terminating, right? So we have to go on. So 1 more 0. 7 times is 112. 16 times 7. Okay, the remainder is 8. Again a 0. 16 times 5 gives us 80, and the remainder is 0 now. Okay, so the answer is 0.1875. Simplify, carry out the process. That is it. Okay, moving on to the next one. 132 over 8. 132 comes in the table of 11. It's basically 12 times 11. Okay, so 12 is 4 times 3, right? Because here I know it's 8. I don't have 3 over here, so I'm going to put like this, 4 times 3, because this is 4 times 2, right? So 4 times 3 times 11. Okay, and this is 4 times 2. So time to cancel the common factors, and we are left with 33 over 2, right? 3 times 11. Now, again, if you want to go do that long division, you do it. We will do that. But let me just show you a trick as well here. Okay, so you know 30 divided by 2 is 15, right? 32 divided by 2 is 16. Okay, so 2's table is quite easy, so you can go on like that, right? But this is 33, 1 more. So 1 is left again, right? So 1 by 2 is how much? 0.5. Right? So this is actually 16.5. Okay? So this is how you can go faster. So if you want to go this route, 33 divided by 2, you can do that, right? 1 times 2, 1, 3, 6 times 12, 1, 0, point, you put here, 5. This is the same thing as here. Okay, so these are tricks to solve faster or tricks to confirm your answer, because if you're strictly told in your exam that you have to do the long division, then you have to carry out this process, right? So this is a way to confirm your answer as well. Or sometimes you want to show that you know a lot, you can use these tricks to amaze people. Next, what we have is 48 over 50. Okay, so now here we will do this as 2 times 24 and 2 times 25. Okay, I'm not going this further because anyways I'll have to then multiply and get them back. If I had written, I could write it as like, okay, 2 times 2 times 24 is 12, right? So 2 times 2 times 2 times 2, this is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 3 is 48. I could have done this, but then what will happen is like this. Okay, so I cancel this, then again I sit and multiply. 2 times 3 is 4, 4 times 3 is 8, 8 times 3 is 24. So this is 24 over 25, which I'm having here also, right? Because I know we don't have common factors otherwise, like numerator and denominator do not have anything in common. So I'm leaving this numbers as it is, because getting this format and then again multiplying to get this format, it's time consuming, right? And it's not smart to do that. If you know things, do it smartly, right? So this is 24 divided by 25. Okay, so we put 0 here and a decimal here, right? 25 times 9 will give us 225. These tables are much easier, right? 25, 50, 75, 100, 125, 150. You go on, it's just adding 25 each time, okay? And that is much faster. So you know that 25 times 9 will give us 225. This gives remainder of 15. We put 0 here. We know 25 times 6 gives us 150. Okay, so the answer is 0.96. Okay, quite simple. I hope so. Now here, 14 and 128. Okay, again, we'll try and have common factors. That's like 2 times 7 gives us 14. And this is 2 times 64. I'm not factorizing this further, okay, because I know I can't cancel, right? So I'm leaving it like that only. So here again, 2 and 2 gets cancelled, right? So I have to have 7 divided by 64. That's what I'm left with here, right? So this is not doable, so I put 0 and I put a decimal point. So this is 1 times 64, right? This gives remainder of 6. I put 0, not possible, so I'm going to add a 0 here, right? Because after putting 0, I'm not able to do it. So I have to put 0 before I insert another 0 over here. Okay, and then 64, this is very close. If it was 64 times 10 would be 640, right? And this is very close to that. So 64 times 9 we will try. Okay, so 64 times 9 is 576. Okay, so this gives the remainder of 24. Another 0, right? So 64 times 3, basically 6 times 3 is 18, right? And 6 times 4 is 24. So this has to be less than that, right? So it's 3 times. Okay, so 64 times 3. Again, you can do this. 6 times 3 is 18. So 60 times 3 will be 180, right? And then 4 times 3 is 12. So this is 192 basically. So you can go that way to get this answer. Okay, so I need to write 192 here. So that gives us the remainder of 48, right? Because 92 plus 8 gives here 200, and then 40 from here, right? So 48. Then you put 0 here. Then this is 64 times 7 gives us 448. Okay, again you need to see this. 6 times 7 is 42, right? 6 times 7 is 42, and 6 times 8 is 48. 6, this is 480, right? 48, but this is not 6, this is 64. Okay, so we need additional, and that's why we are with 7 here. Okay, so this is 448 gives remainder of 32. Okay, we'll put one more 0 here, and this is 5 times 320. So the answer is this, 0.109375. Okay, so it was quite a long process. Rest all were quite simple. This took us a little longer. Okay, but this depends upon the number that you're trying to solve. So this is the process. Okay, so remember, first always simplify. Whether you are asked or not, as far as possible, try and simplify things so that this calculations become much easier. Okay, so we move to the next part here now. Again, it's a long division method, but here they're saying it's a repeating one. Okay, right? Using long division, write each rational number as a repeating decimal with 3 decimal places. Identify the pattern of repeating digits using bar notation. Okay, so we have the first number here, which is 5 divided by 6. So what are we going to do now? We have to follow the long division method, right? So let's get going. 5 divided by 6. Okay, so we put 0 here and a decimal point here. 6 times 8 gives us 48, right? 2, we put again 0 here, right? 6 times 3 gives us 18. Okay, so remainder is 0. Do you see the pattern? 2, we'll put 0 again, 3 times, this is 18, and it goes on and on, right? So you see this 3 will keep repeating. So this is 0.83333333. So what are we going to do? Let's say 0.83 and put a bar on it, saying that this is the digit that's repeating. Okay, so that is it. A simple thing to do there, right? Next one we have is a mixed fraction. -8 and 2 over 3. As we did before, we will not touch 8 at the moment. We'll play only with 2 over 3. So let's do it here. 2 divided by 3, right? So we put 0 and a decimal here. Always when you put 0 for the first time, immediately put a decimal point so that you never miss on it. Okay? So this is 3 times 6 gives us 18. 2 is the remainder. So this process will go on, right? So again you put 0, again you put 6 here, 18, 2, and goes on and on, right? So this, as we did on the previous page here, right? So where we kept this numbers as it is. So we are going to keep this 8 as it is, 8 point, right? And we take this points and number digits from here, 6, 6, 6, 6, 6, 6. So how are we going to write 8.6 and then the bar on it, right? Because that is repeating. So this was just two simple sums over here. Okay, repetition. Whether it's terminating or repetition, we know that the process is the same. The only thing is in one it ends, in another it doesn't end, right? Okay. Next, what we have is write each rational number as a repeating decimal using bar. So basically, they are asking us to use a calculator here because they're quite tedious, big numbers. So what I've done is, this is what is given to you, okay? And this part is already done. This is not given to you. I've used the calculator and got these answers, and I've written it here, okay? Just to make our process faster, because anyways you have to do using the calculator. So let's start putting the bars over here. So this is, what do you see here? 1 4 5 4 5 4. Okay, so what do you see? What is being repeated here? What is repeated? 4 5, right? 4 5 4 5 4 5. So this will be 0.145, and you put a bar on 4 5, right? Okay, likewise we'll be doing for each of these. You can try doing them yourselves first. You can pause the video, do it yourself, and then come back and check your answer. Or if you need an explanation, you can look for it again. So here, this will be 3 point, right? 70731, 70731. Okay, so this is one time. This is it. This is how it's repeating, right? The 70731 with a bar. Okay, simple. Let's go with the next one. This is -8 point. What do we see? 9, 7, 2, 7, 2, 7. So 9 doesn't repeat, so we'll write 9 as it is. 7, 2 keeps repeating, so we'll put a bar only on 7, 2 and not on 9. Okay, here also we didn't put a bar on 1, right? Then the next one here, 0 point. Let's see, this is 7, 8, 857,142. 857. Okay, so 7 is there as it is, then 857,142. 85, then again you have 857,142, right? So we'll say 857,142, and the bar starts from 8 until 2. The bar is not on 7. Okay, next one, 0 point. Now it says 76923076. Okay, so 769230. The entire thing has a bar. This is quite simple, right? Answers are already done using calculator. You just have to put the bar notation. This is 39.6534, right? So 6534 with a bar on it, and you are done with it. Simple. It's not too difficult at all. Okay, it's just putting the bar, identifying the decimals, the digits that are repeating. Okay, next one. Write each rational number as a decimal with at most 6 decimal places. Again, we had the calculator here. So I've done the calculations already. Okay, so we are going to put the same thing we'll do here. So here there's no repetition. We'll leave it at, it says at most 6, which means maximum you have is 6 decimal places. Okay, so here we have 5, so we will leave it as it is. We are not going to do anything with it. Okay, and it is a terminating one, so we leave it as it is. Then the next one, you see 6 being repeated here, right? So this is 0.46 with a bar on 6, right? Okay, then the next one here, minus 0 point. Let's see what is repeating. There's no repetition here. There are no dots over here. Okay, so it's not like a non-terminating. It goes on, but there's no repetition. So 7345309. So it says at most 6. We need maximum 6, not more than that. Okay, so let's count how many numbers do we have until 1, 2, 3, 4, 5, 6, 7, 3, 4, 5, 3, 0. Okay, this is where 6 digits end. Now the next one is 9, and you know the rule. When it's 5 or more than 5, you increase this digit by 1, right? So let's say 7, 3, 4, 5, 3, 1, and not 0. Okay, because next number is 9, more than 5, right? So this is what we will write. Again here, non-terminating 0.7 30692076. Okay, so from here, if you see 276, this one 7692. Okay, 0, this part gets repeated, 076923. Okay, these are the digits repeating. Do you see here, 07692, and it would go on that way, right? We need 6 decimal places, so we'll write 73 as it is, right? And we write 0769223 with a bar on it. Okay, the next one here, what do we do? How do we do it? What do we see here? 0.84090909 keeps repeating, right? So that is it. Simple. Okay, now it says arrange the above numbers from least to greatest. Place them on a number line. So we need to arrange these numbers from least to greatest. So we know from least to greatest, we'll first put our negative numbers, right? So let's see which are the negative numbers. We have these as negative, these as negative, and this. These are the 3 negative numbers that we have. Now we need to put the least one first, right? So let's start comparing. All of them after decimal has 7. Here it's after the second digit after decimal is 1. This is 3. This is 3. And you know, for negative numbers, it's a reverse, right? So if it was positive, 3 would have been bigger. But since negative, they'll take 1 as the bigger, right? So this is out. So we need to compare these two numbers now. The third digit here is 0 and the third digit here is 4. Right? So normally this, if no negative sign, then this would be bigger, but it's negative sign, right? So this becomes a smaller number, right? So this will be 368 over 501 less than, this one was, we were comparing this to, right? So this will be the next one, 19 over 26, and this is the only negative number that we are left with. So this is how it goes, right? Okay, now we are left with these two numbers, positive numbers. Let's compare them. The first digit after decimal is, here is 4 and here it's 8, right? So obviously this is bigger and this is smaller, so this number will come first. So this is 7 over 15, which is less than 37 over 44. So this is how we arrange them. Then it says place them on a number line. Okay, so let's do our number line. Here we are. I'll be doing it two ways. You see which works better for you. Okay, so let's draw this line. Let this be 0 here. Okay, now what I'm going to do is this thing indicating there are numbers here in between. Okay, and I start this number from here. So now here what I want is all is 0.7 something, right? So I'll put my 0.7 here, and this will be my 0.71, 0.72, 0.73, and 0.74. Okay, so this is minus 0.7, this is minus 0.71, minus 0.72, minus 0.73, and this is minus 0.74. Okay, so first we have a 71875, right? 71, this 875 has to be between, this is 71 and this is 72, right? So it's 8 over here, right? So here 1 centimeter I've taken is a 0.1 unit, right? 0.01 unit. So I'll mark this from here 8 number, right? So 8 here. So this becomes minus 23 over 32, this number here, right? So this is my number here. Okay, then it says these two numbers, 7307 and 7347, right? So 07 will be closer to this and 45 will be a bit away from here, right? So very close, it's 07, right? So it's going to be very close to this number. So the first unit itself I will take, and this is 3, 4, 5. So let me take 4 units away. Okay, so this is 4 units away. Then this is minus 368 over 501, and this one is minus 19 over 26. Okay, then what I have on the positive side, I need 0.46 and 0.84, right? So I've done this here, right, saying there are numbers, and this saying, so this side my scale does not remain same as here. So there is 0.4, 0.5, 0.6. Let me extend the line. 0.7, 0.8, 0.9. Okay, I don't need it, I'll just put it like this. So I'll start with 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Okay, do you see here I was going like 0.1, right? 0.1 is here. Here I'm going 0.01. So when I said 0.7, I didn't go next is 0.8 as I did here, okay? Because this way my scale becomes better. I'm putting two different units on two different sides, and I'm giving this marking over here. Then it says 4, 6, right? So this is between 4 and 5 over here. So 6 units, I'll take 6 units. This one. So this is 7 over 15. And it says 8, 4. So between 8 and 9, right? I'll take 4 units here. So this is 37 over 44. Okay, so this is one way of doing it. If you're not comfortable having these two different scales on the same line, and if it's not allowed, then you can do this way, where we keep this scale as it is. So I will not do this part here, so I'll go just down here. Okay, this positive side will remain as it is, right? I'll go here, I put my 0 over here, right? And whatever that marking is, I come here, I say this is my 0.7, and this is minus, and this is minus 0.8. Okay, so just keeping the scale same as here, right? 0.4, 0.5, 0.7, 0.8. Okay, the same. This one will remain the same, so I'm not plotting it here. And now you start plotting this. So it's 7, 1, 7, 3, 7, 3, but this is 7, 3, 4, 7, 3, 0, right? So now each tiny point I need to take here is 1 unit. Okay, this is minus 23 over 32. Then I have 3 units. This is also 3, this is 3, but this is 3, 4, and this is 3, 0, right? So on exact 3, I will take 1, and on around 4, I'll take another. Okay, so around 4, what I've taken is this, minus 368 over 501, and this one will be minus 23 over, sorry, minus 19 over 26. Okay, so I'm keeping the scale same on positive and negative side. Okay, and this as it is, as I said. So either of the ways that makes sense for you, and whatever is allowed to do in your schools. Okay, so this is my scale over there. Now we are on the last sum, and then we're done with the chapter. Wow, that was really quick and fast. So let's read this question. It says Maria tries to compare minus 2 over 3 and minus 5 over 8 using absolute values. She finds their decimal equivalents to be minus 0.6 with a bar on 6 and minus 0.625. And she knows the absolute value of 0.06 minus 0.06 is greater than the absolute value of 0.625, right? Because then when you take absolute values, the signs are, or the negative sign is not there, right? Explain why Maria must reverse the inequality in her final answer. Now this is without the absolute value. This were the absolute values, so the negative sign didn't matter. Only the value of the number mattered and we compared, right? Here now the absolute sign bar is taken out, right? So you know why she has to reverse it, because here we're not talking about absolute value anymore. This is not absolute now, right? So of course she has to reverse the sign. So that's what you got to write there. You know it, right? As we just discussed, you just got to formulate the sentence and write it over there, because in the final answer she's taking the numbers as they are, just not using the absolute values. That's why she has to reverse the sign over here. Okay, so this is it, just 23 sums. We just solved all of them. Yeah, okay, so that is it, and you can look out for other videos that helps you understand other concepts of the other chapters, as well as helps you deal with independent practice. And as I always keep saying, that try and do things yourself first. Watch out the videos and take help from there, but don't become dependent on it. Okay, because you need to learn, you need to practice. The more you practice, the better you will get at it, and one day you'll be solving as I'm solving, and maybe much faster and better than me, because you have practiced enough. So thank you very much. Have fun, enjoy math, look other videos, and help yourself. Thank you. Bye bye.